All right, let's get going here. Welcome everyone to our very first LinkedIn Live. We're getting a 2-for-1 special. We've got the DevRev team here combined with Bespoke Labs. So I'll start with DevRev. My name is Ahmed Bashir. I'm leading the engineering team here at DevRev. And joining me from DevRev, we've got Anshu and Ritesh, both from the AI team. And Mahesh, you want to go ahead and introduce the team from Bespoke?
Yes. Hey everyone. It's great to be here. Thanks, Ahmed, for the intro. So, my name is Mahesh. I'm a co-founder and CEO of Bespoke Labs, and along with me are Ryan and Shreyas, two of my founding engineers. Before jumping in, I want to say a word about Bespoke Labs. So, basically, at Bespoke Labs, we believe that everyone should be able to customize open source models to their use cases and to their workflows to get frontier performance with post training. And when I say post training, there are many aspects to it, but in this webinar we are going to touch upon just supervised fine tuning. So with that, I think let's kind of take a example of an agent in DevRev. Anshu, do you want to kind of walk us through that?
Yeah, sure. So here, like we see the develop platform, and here we see a list of tickets view.
And do you mind if I just kind of show the people what we're looking at here?
Yeah,
Okay, sounds good. So, folks, before we get too deep into it, Anshu, maybe you can make the screen a little bit bigger so we can see the text. So, this is a very simple screen. For those of you who aren't familiar with DevRev, we're basically reimagining work software in the era of AI. So, generally speaking, in a nutshell, we're connecting all your most critical integrations. In many cases, we serve as your system of record for specific use cases. In this particular case, we're talking about a fictitious organization that is doing ticketing using DevRev. So what they've done is they've either brought in all their tickets or have started to use us as their primary source of truth for ticketing to solve for customer problems. So that's the theoretical use case we're using here. And this looks like maybe any ordinary work software where you can see a list of tickets. However, what makes this special is that we are able to combine this with search, analytics, and automations. In this particular case, what we'd love to do is show you what a conversational experience could look like when you're accessing your tickets. So maybe, Anshu, we can start with that experience and see how we can make it better using fine tuning.
right. So like while I have the list view, and each of these tickets have like we see like around 700 tickets here. Each of these tickets have like multiple fields, and like you can filter on these fields like with blocker severity or the things like open and so on. So what I want to do is that, like, let's say just try to ask some questions here conversationally, that like I want to like show me blocker tickets which are still queued, and what I want to do is I want to like send reminder to their owners, and let's see what this conversational AI comes back with. So you can see that like it's starting to stream its thoughts, and then it says that like yeah, it found some blocker tickets, and here it lists down like those blocker tickets which are like still queued, and it listed down the five blocker ticket which are still queued and asked me to do a follow up. And if I like go here and show that, like, let's say we have severity as blocker, and stage as, let's say, queued, you will see those five tickets which are listed down here.
Fantastic. So now if we want to make this even better, I mean, are there queries that you could ask? Are there conversations you could have where maybe the results don't really yield the exact results that you're expecting?
Yeah, like I can try a few more queries. Let's say like show me tickets which were modified this week. So and then let's see what it comes up with.
Okay, and what's great about this experience is that you're not only getting the conversational experience that's built into the product, but you can actually, and we're going to see this in a couple of minutes, you can actually go in and actually configure skills with specific prompts, knowledge, and instructions that can help you get the most out of this product by customizing the experience, by personalizing the way the conversational experience works for you. And that's where I think we're going to be heading next.
Yeah, so while this is great, like what in this webinar, what we want to do is like go behind the scenes of how is this like agent exactly built. And in DevRev, we have this agent page. So behind the scenes, like what we have done is we have created a very minimal agent with very minimal prompt and some set of skills. So here, if you see, like we have an agent page where it says the instruction is that like you are a helpful assistant and be helpful and polite. That's it. And the key ingredient here is that uh, the core of the agent is an LLM, the base LLM, but it also needs information about your organization, right? So the agent was able to tell answer questions on the tickets which are on DevRev. So for that, like we have this skill which is called ticket search skill, and we will actually go deeper into that skill. And we also have this experimentation pane on the right hand side where I can ask the same question like show me blocker tickets which are still open. So I can like ask this question here as well, and it will again give the experience. And this is the agent which you are seeing here, and you can go and modify this and the experience will change here. So let's take a little bit deeper dive into the skill which I'm talking about, which is the ticket search skill. So
Yeah.
in the
So more or
ticket
less,
search,
you're
yeah.
showing us. So you're basically showing us a bit of a playground. First, starting with being able to summarize exactly what the instructions are, the skills, the knowledge, and then of course being able to test it out. And then of course you can go into that skill like you just did and see what the specifics look like.
Yeah. And just to recap, the agent has some prompt like which is very minimal here. The entire secret sauce is inside this skill, and that's what we are going to look at behind the scenes, what's happening. And in the skill, the first step is that like we get the input from the base LLM, whatever we have chosen for the agent. And then the next step is that we have another LLM which we are asking to say that like now predict the filters. The question was in this example, show me blogger tickets which are still open. Behind the scenes, what we have is that like we have the user prompt which is going in. We also have a system prompt here which says that like yeah, you are a helpful assistant and so on. And it has the entire like the schema of the tickets and the DevRev and so on. And we pass all of that and say that we also have the schema of this our search query where it says that like this is how you should be doing search and so on. These are the stages and so on. So we have this big prompt and which is given to the model, and then this model will output that like these are the filters which need to be done. And then we have the search API. This is the DevRev search API. It what it does is that like it takes the filters which we have and then makes the search API call within the DevRev and then passes the output back to the agent to respond. So if you see the respond here, that like it was not just showing me the list, it was also asking me to that like would you like me to draft reminder messages for the owners and so on. So what it did was took the output of the search and given this query also drafted a complete response here. And what's great about DevRev is that in this skill you can actually see the the inputs for each and every block which I showed here. So take this example, the latest example where let's say we want to like what we had done was we not this one, let's pick the other one here. Actually, yeah, this is the old one. Let me just refresh.
Yeah. And while you're refreshing that, I think there's a couple of questions from Pritesh. Um, he's asking about catastrophic forgetting about during fine tuning. I think we'll get to that question, Mahesh, later on when we are actually showing the fine tuning. Once we've kind of set up the premise here. And I think Pritesh, your other question about it has access to all the tickets and we can add an agent that automatically sends reminders. I think yes, the premise here is that you can add an agent that can basically create ad hoc queries with filters. It can also take actions, and yes, that's one of many things you can do by building skills. And and maybe in a subsequent webinar we go deeper into all the different types of nodes that you can build into the automations. In this particular case, what we're going to do is really kind of just go deeper into this one specific action that we had created. This specific action being, let's use a model to actually understand how to take the language that we've specified in the conversation and actually prepare a query and a set of filters. And how do we do that exceedingly well? And that's going to be sort of the exercise that we're going to go through here. But I think, Anshu, you've got something on screen you want to show us?
Yeah, so I clicked on the operation of where it said that like we asked the LLM to predict the filters, and here we see the output. It said the state should be open and severity UNM is 1, which stands for the blocker, and it is correct. And like in the next step, what it did was like it actually showed the search, and that goes as input in the filter like state open UNM, and you can also see the output of the search which DevRev did. So you see the search results here. So like
Yeah.
the developer has a nice visualization of like what exactly is happening inside the agent. And in this webinar, like we will actually try to improve this particular node where we say that like it's taking the user query, giving the output as filters, and how well we can improve the filter. But before even like we do improvements, like we have to think about that how even I am evaluating this agent, right? Like I just issued 2 queries. Like is it good enough for me to like launch this prompt to production? No, like I actually want to test it with thousands of queries and then come up with an accuracy number before
Yeah.
even I launch it to production.
Yeah, I mean, to said another way, this is fantastic. I mean, a playground experience is really good to test out with 1 or 2 sample queries how we're doing. And obviously, you want to do that before you take anything live. But if you really want to see how good you've done with creating this node, perhaps the prompt, the quality of the information that's going into it, you're going to want to actually create a data set that allows you to see what percentage accuracy you have and how reliable this thing is to understand human conversations and interpret queries out of it. So I think what we want to do next is maybe understand what kind of tools we have available to actually do a good job with that.
Yeah, totally. And I think this is where I can jump in and fire up this notebook we have here. It's where the real fun, the real work starts. So we've got this interesting use case. We've got this workflow, which kind of works. We're not really sure how too well it works. So the first thing we're interested in doing is evaluating the abilities, as Ahmed said. And then once we know the abilities, we want to improve upon this. So what's nice here is that both of those things require a data set. They require a evaluation data set and they require a training data set. So I have a notebook here where we've installed a couple libraries, Curator and data sets. I'll talk a little bit more about Curator, and I'll just run these cells here. And I'll actually work backwards from the data set that we're generating. So just to connect it to what we just saw on screen, we want to have pairs of natural language queries that the user will enter into DevRev and the search query that the workflow should run based off of that natural language input. Mm-hmm. So right now, as we saw in the example, it can work on simple queries, but on more complex queries, that's not the case. And I actually did want to point out that the second query that we ran, it took a while to run. So not only do we care about correctness here, we're also, when we're fine-tuning a model, we also get boosts on latency in terms of speed and also costs. So
obviously, I mean, there's many other considerations as well. When we get into the fine-tuning, I guess we can discuss those. But this is pretty interesting. And you're telling me that this is, obviously, we're looking at Google Colab, but are we going to be using very specific tools within this to kind of speed up the generation of the data? Because I know that can take time.
Yeah, absolutely. So this is where we're excited because Bespoke Labs has been creating Curator, which is a tool that makes it very, very easy to generate synthetic data sets. So once again, working backwards here, this is how simple it is to use Curator. You define this process to create a synthetic data set, which is simply an input to a model that you're calling and then parsing that output into a data set. And then you specify which model you're calling and some generation parameters, and you just let it rip. So let me work up here into the nitty gritty details of how we're generating the synthetic data set, because at the end of the day, the quality of your model is going to directly come from the quality of your data set. And that's where you're going to be doing a majority of your iterations. So here we have a pretty simple setup where, as you can see, we're constructing this data set, which are the pairs of natural language queries and the search queries. We're also asking the model to determine the complexity level. So this is another place where you can get into a little bit more interesting data work where you could filter based off of the complexity level if your model is not doing well at the harder queries. But for now, we're just keeping that. And then here, when we're calling this teacher model, which is Claude 3.7, we're actually distilling from its knowledge, so it's superior knowledge. So you saw earlier in the workflow, we were using GPT-4o Mini because we have requirements for speed and cost and latency here. So the goal here is to even further improve that and also further improve performance. So if we just scroll up a bit, we have our search query, which is defined by two things, as we saw before, filter and then a semantic query. So let me actually go even deeper and just show you these prompts, which we're going to use to generate the data set, which DevRev has done a lot of work to generate. So let's get into that, Ritesh.
Yeah, I'll walk you through the prompt. So yeah, basically what we want is Claude to be able to generate natural language sounding queries and in DevRev's hybrid search filter expression. So for Claude to be aware of this, basically we give all possible knowledge that is specific to DevRev. So here we see in the start of the prompt, there's everything that describes object model of DevRev. Objects are basically entities in DevRev, and ticket is one of such entity. And if we scroll down, we also see we'll be providing Claude with entire Wisp or our search query language. That is basically the DSL that describes our given a query, how would you want your filter? So given this information, what we ask Claude is to generate natural sounding queries. And also, if we see the user prompt, generate complexity. The reason why we make it to generate complexity and reasoning for that is to improve the distribution of overall queries. So there's queries that are ranging from low complexity to high complexity. So your student model sees the entire distribution.
Yeah, and I just want to jump in here that diversity of your distribution is really what's important here with synthetic data. If you're just asking the model the same thing over and over, you're going to, after a while, just get the same things back. So this is a great strategy here. We're asking it to generate a level of complexity. And then also you can see here, we're asking it to generate 20 or 30 pairs per call to the model. And this also helps with diversity, because as the model is generating, it sees in its context those previous examples that it's generated. So it's very unlikely to repeat those again in the same list. So what we do is we make individual calls where there's 20 or 30, a list of 20 or 30 paired queries coming back, and then we unroll that and stack it into a data set together.
Britesh, one question here. Like how we saw the prompt which you had written for the model, GPT model. How did we arrive? Like, how different is that prompt from the prompt for dataset generation? Like, is there an overlap between them, or like how can people come up with, like, let's say they have written a prompt for the actual agent. How do they convert that prompt to this prompt?
Yeah. So to answer your first question, what's the prompt for GPT-4o Mini? So we start simple. Like we can just ask it to generate a query, and we know that the generation would be wrong because it doesn't have the query language to understand it. So then we add in the query language, and we iterate on top of it. And even then, what we saw was whenever it's dealing with entities from DevRev, especially mentioning or referencing some IDs, there's an accuracy drop. So we decided to add some information that explains object model of DevRev so that there is everything in context. And the prompt we see here is basically an expanded version of that. So, and the exact difference between your inference prompt and data generation prompt is what we see right now on the screen. We ask the model to generate the query and filter as well. Whereas during testing or inference, you give a query and let model come up with the exact matching filter for that.
Yeah. And I think there's actually the data set that we're generating here is a relatively simple first step, but because you have more privileged knowledge when you're generating a data set, there's more interesting things you can do. So we're asking it to generate the query, and the natural language query and the search query together. So the idea is that those would be correct, but you could also do things like generate the search query and then back translate into your natural language query, or you could take your pairs of queries and then actually execute the search query to see if it runs and do some simple validation and rejection sampling. But for the purposes of this demo, we'll stay with this first starting place. So let's actually get now into running Curator. So just to remind you, we've determined what the structured output of the calling the teacher model is going to look like, and then we're going to unwrap that structured output into a data set. So here I'm running Curator, and Curator is really great. So as you can see, it's printing out a lot of things here. It handles a lot of the back end for you. So what it will do is it will maximize the speed of generating the data set and having as many concurrent requests as possible. And if there's any errors, then it will also deal with those and deal with retries. So you actually just saw I ran it, and Curator is really smart. So it remembered that I just ran this previously. So it actually loaded from the cache. So that's another feature of Curator. So I just changed the generation parameters a little bit to force it to rerun. And this is actually really helpful when you're doing data iteration, and you only have to rerun the parts of your pipeline that you're changing.
Yeah.
So
if you don't mind me jumping in, I mentioned
Yes.
a couple of points just to underscore what we've seen in the last 5-7 minutes. One is sometimes the simplest tools are the most valuable. So being able to create a data set at scale means you have to be able to parallelize, be fault tolerant, and also leverage sort of the best practices that we have around using LLMs and, of course, just engineering in general. So to be able to have that sort of packaged together in Pure Curator for us is very, very useful. We do generate synthetic data sets for many different use cases. It's usually step one in being able to evaluate specific skills or evaluating the efficacy of a specific type of AI problem that we're trying to solve. Number two, and this is something that many of the people in the audience have observed, is that these prompts that we've looked at, they are complex. I mean, it's not like it's a single paragraph. These are relatively complex, and they may look a little bit daunting to begin with. However, a couple of things to understand is that prompt engineering is increasingly a skill in and of itself. And there's obviously many prompt libraries out there and many different things that people are doing to kind of share best practices around this. And it's a part of being able to understand how to create a better product using AI. But remember this, the premise of the example that we've started this conversation with had to do with actually answering questions, ad hoc conversational natural language questions that have to do with the entire business of this fictitious company. And so we have to understand that there's many, many different example scenarios where the problem statement that we're trying to solve it would have in a previous world been an entire feature that would have taken, let's say, weeks or months to develop. And here we're trying to approximate that by extending a conversational agent that we already have inside DevRev. So while it might look like it may take several days, hours, or maybe a couple of weeks to actually get to the exact experience that you want, here we're going to try to compress it in 60 minutes. But you can see why the actual premise of the problem and the actual value that you're generating is there. And so it's well worth it to actually invest that extra time to actually prepare the right prompts, to create a good data set so you can properly evaluate what it is that you're delivering and being able to sort of iterate on that over time.
Yeah, that's great. Thank you, Ahmed. And here we have on screen, as you can see, Curator also tracks statistics like time and cost. So I'll just quickly share this other screen. So we're actually looking at the Bespoke Labs data viewer here. So we're looking at the output of the data set that we've just generated. And as we said before, there's these pairs of natural language queries and search queries. And then there's this complexity level. So if we click into this, we can see, okay, show me tickets created in Q1 2025, and it has this filter here. So that's a simple query, and then we can scroll down, find a query that has a complexity level 2. Here, there's both a filter and a query being applied to find API integration issues awaiting development. So the idea here is that we are distilling from the teacher model, which is quite good at concocting these pairs, and we're also trying to cover a wide enough distribution where at inference time, when we plug this back into DevRev, we're able to accurately generate queries there. So let me switch back, and here there's a little cooking show. We've pre-generated a larger data set, and then here we're splitting that into our train and test. So as we mentioned before, we need to evaluate to see where we stand, and that's really important because you can't really improve what you can't measure. So we first need to figure out where we're doing with the model that we currently have. So once again, these are the pairs. And what we're going to do in the evaluation here is we're going to treat the teacher model as the ground truth, and then we're going to compare our candidate model against that. So here we're just simply formatting it for the training data set, which we'll upload and look at later. So let's get into the evaluation. Once again, Curator is an all-around tool for doing bulk inference. So bulk inference is great for generating synthetic data sets for training and for evaluation, but also for the evaluation process itself. So as you can see here, we have a judge, which is comparing the ground truth answer against the model which we're evaluating. So let me just go ahead and run this evaluation quickly on GPT-4o Mini, which was the model that we saw later previously in DevRev. And you can see we have multiple Curator instances flying out here, and we will just count the number of instances and look at the percentage of them that are correct. So yeah, so here we can see we're around 28%. So that's our starting place, and this is where we're going to iterate from.
So let me just summarize what we've done. We've basically used Curator to quickly create a synthetic data set that represents these pairs of conversational questions and query filter pairs. And then effectively, we've used the eval process to understand how effective are we given what we have today, using the model that we have today. So effectively, with what we've built, that skill that we started with, what we found is if we were to evaluate it using a very large data set, we are only 28% accurate in terms of being able to answer the exact question that was asked in natural language.
Exactly.
Okay.
And also one other thing I want to mention is, Curator is open source, and you can actually find it by searching for bespoke Curator. And not only does it take care of all the engineering issues like parallelization and so on, but we also are trying to build in recipes for fine tuning into Curator, right? So, for example, how do you generate diverse data? How do you measure the data quality and things like that? So basically, we are bringing in like the data-centric view of how to improve AI, so that you start with the data, iterate on the data, and then go into eval and fine tuning.
I mean, in this case, 28% for the skill we just created, that's obviously not going to cut it. So how do we make this better? I know we've got a few different options. We can make a better prompt. We could do some other things. Shreyas, maybe you can jump in here.
Yeah, I can quickly say about what are the different things on how to improve the model. So as Ahmed said, that prompting will only get you so far, but yeah, and after some time, it's unclear on how to improve the model. So definitely one of the ways is to fine tune the model and using synthetically generated data to actually distill the prompt into the model's weights. So there are multiple ways of fine tuning. Maybe Mahesh can go into like what are some of the ways and why we choose SFT.
Yeah, sure. So as I was saying, that the broad range of how to modify a model is called post-training. Actually, I wanted to give a mental model around this, right? So when you are prompting, it feels like what I think of as like you're whispering into the ears of a LLM and telling it to behave in a specific way. Whereas with the post-training, you're actually modifying the LLM to fit the mold of what you're trying to create, right? The product or the specifications. So that's the trade-off. So if you want some kind of flexibility, prompting is great. But if you know exactly what you're doing, then and you want to basically get the best performance, then you want to be able to post train the model. So with post training, there are a bunch of methods. So one is supervised fine tuning, and then there is preference tuning and reinforcement learning. So supervised fine tuning, what it does is you have questions and answers, prompts and responses, and you basically you curate a bunch of this, and you teach the model how to do the mapping between the question and answer, so that it's able to, given a new question, it's able to answer the question. In preference tuning, what you're doing is you're kind of teaching it what's a preferred answer versus what's a not so preferred answer. This is typically when the model is you're finished doing fine tuning, but sometimes it just doesn't feel like it's giving the right way of responding either to your business, or in LLMs that there has been the RLHF thing, so that we are aligning to human values. So that's where preference tuning comes in. We don't necessarily need it right here. And then there is a reinforcement learning. So that's the new paradigm of teaching models how to behave. There it's more on the trial and error, right? So you kind of you don't necessarily have to give the question and answer, prompt response, but you give just the prompt. The model does trial and error, tries and fails, and then we kind of guide the model saying, okay, this was a good response, this is not a good response, and then it basically learns. So that's a lot more flexible way of doing things, but it needs a few other things to happen, like setting up the environment and so on. But the great thing about RL is that it actually makes the models reason better. So that's the new paradigm that we are seeing, that people are actually using RL, and we are also using RL to build agents. So maybe that can be reserved for a future webinar, but today let's focus on SFT.
Yeah, so let me present.
I guess we've got a couple questions about evals. Maybe we quickly go over. So I think, the first one was, does the test split cover a uniform range of queries by different complexities? And the idea would be, yes, you'd want that. And our synthetic data generation process, as you saw, had a bunch of different queries at different levels. And I think it's important not only to measure really hard things, but also really easy things, so you know that your model does not regress at those things as you train it. And also it allows you to get signal at a smaller scale. So let's say you're dealing with bigger models or bigger data sets, you want to figure out what good strategies are before scaling up if it's quite expensive. So I think that's really important.
And if I may add one more thing here, basically one thing you do want is like more than complexity, you want to kind of have the test data in distribution with what the users may ask. So oftentimes if you have actually the logs of the questions that users ask, that would be your perfect test data, right? So that's and of course then you can also kind of push the model to see if it's able to answer harder questions and things like that. And then there is one more question on what are the most effective methods you use to evaluate performance of LLM based agents. I think again, it depends on the use case, but one thing we kind of try to do and try to utilize is like you want to do evaluation, but also method of error analysis. So evaluation is like where you get different metrics. So there are various ways of doing eval. For example, you want to say compute precision, recall, or accuracy, or sometimes AUC and so on. And then there is the other aspect of error analysis, where you actually look and read at what the model has done. And then maybe you can even use other LLMs to kind of classify and so on. But you want to get a sense of what are the mistakes the model is doing, so that you can then improve upon your basically existing data.
Okay, perfect. So maybe we take our 28% and start to focus on the fine tuning next.
Yeah. So yeah, here we have a simple collab of the fine tuning demo. I have just kickstarted this fine tuning job, but I wanted to take a step back and explain why we have created this fine-tuning infrastructure. So for fine-tuning, typically the workflow of an AI engineer would look like, okay, you have a GPU cluster. Let's say you have an H100 node, and you want to schedule your fine-tuning jobs there. So the first step is to like load the environment, because usually people go with some open source repos for fine tuning. So setting them up and making sure they work is not a very trivial task. You have to like ensure all the dependencies are correct and it's using the hardware as much as possible. Once the environment is set up, you have to also ensure that the jobs are being run correctly, like they are using as much of the resources as possible. And the utilization of the GPUs is high, because these GPUs are like kind of expensive to have and maintain. It's having a higher utilization is very important. And again, like when you run these fine-tuning jobs, you typically run into various memory issues. Jobs kind of stop in between and things like that. So this is actually a pain point for our fine-tuning runs, as well as the fine-tuning runs of the customers that we work with. So we have created a way to do fine tuning using a simple collab, and we will take care of all the infrastructure needed to do the fine tuning and get you the model, get you the fine tuned model. So it's very simple. You have to like again install a curator. You have to set some environment variables, and here's the data set that we are going to fine tune. We have a fine tuning client which interacts with the fine tuning infra that we have. We call the backend as bespoke, and we have the backend parameters as we hit the API dev. So this is similar to the OpenAI's client which you would have for doing OpenAI queries to OpenAI. And this is the job that I've just.
Quick question. Is that data set the same data set that we generated a few moments ago?
Yes, this is the same data set that we have generated.
Awesome.
We have added a couple more columns in the data set so that the data set format can be used for fine tuning. So fine tuning expects the format in a conversational format. It's called shared GPT. So there's a system prompt, there's a user prompt, and the assistant response. So we format the data set into this type and just like send it to fine tuning. But the data is essentially the same as what we have just generated.
Awesome.
So this is the job. I can quickly go over some of the hyperparameters and the model the model that we have chosen. So the model is Quen 2.57b instruct. It's a 7b parameter model. So we have chosen the 7b size. So models come from like 1b to like 500, 600b. So the design decision of choosing a 7b model is there's trade-offs within like accuracy, how easy is it to train, and how cheap is it to infer. So smaller models typically have lower accuracy and larger models have higher. The 7b is a good, like very good starting point. The base model is very good. It performs well in many of the available benchmarks. So for the task that we have at hand, we thought that a 7b model is a good enough base performance, which we can further improve by doing the fine tuning. Also, training a 7b model is on the clusters is very easy. We don't run into like memory issues. Larger models, we run into all sorts of memory issues and communication issues and whatnot. So a 7b model is very simple to train. And also for inference, it's very cheap to do inference on a 7b model as compared to like a 70b or a 500b model. So we have chosen the Quen model. There are different models in 7b as well. There's Llama and there's Quen. So typically we do iterations. We also try both the models and choose whichever performs better in the evaluation set. But also to govern the decision, there's like many other models. We look at like general trusted benchmarks and choose the model whichever performs well in the relevant benchmarks. So we have chosen.
Shreyas, I had a question. So here we could plug in many other models, right? And then would that work? And also, maybe others can, for example, when they are training, maybe they can kind of figure out what's a good size to. Maybe they can even go smaller than this, right? So what are the other trade-offs to think about?
Yes. So yeah. So the first question, like, can we switch to any model name? Yes. So this is a Hugging Face ID. So models are typically deployed on Hugging Face, and we just choose any model that is available on Hugging Face, and we can run fine tuning on it. So yeah, if I were to switch it with Llama or Llama 8B or Llama 1B, it would the same code would just work. So the trade-offs between like choosing a smaller model would be that it would be harder to train the smaller model. Typically, we've seen that it takes many more examples to get the same level of performance improvement with a smaller model. And also, smaller models are have poorer performance in benchmarks overall. So we would need many more examples to get to the level of performance. But with a bigger model, we would need lesser examples. And let's say we have two fine-tuned models, a 1B and a 8B. Even with more examples in the 1B, it's likely that the 8B fine-tuned model is going to be better. So it's just that the base accuracy kind of translates into the fine-tuned model.
And Shreyas and Mahesh, there are multiple libraries as well, right? Let's say we have a Llama Factory, and there are other libraries like TRL and so on, which can be used for fine tuning. So, like, what's the difference between using the libraries directly versus using the curator client here, which we have fine tuning
Right.
client?
Yeah, so definitely we can use the libraries to do this fine tuning. And many of the researchers, in fact, use these open source libraries. But the problem with them is one, you have to have the GPUs to actually run them. Two, you have to like schedule them manually and kind of babysit those jobs as they are running. So let's say you have an 8x H100 and your fine tuning runs for 5 hours, and you start the fine tuning at 8 p.m. Like at around midnight, you have to like start another job. So scheduling is actually a big problem, and you have to have a high utilization of your resources. Otherwise, you're just wasting money. In this case, yeah, the curator fine tuning client just takes care of the scheduling. You can schedule like even 100 fine tuning jobs right at once, which is not possible to do it with like any of the open source libraries available. So it makes the life of the developer who is fine tuning models much easier, so that they don't have to take care of the infra. So the whole pain issues with infra are kind of solved with this.
And of course, there are also other infra like Together and like OpenAI and so on, which allow fine tuning. But in this case, what we have built is something a bit flexible, but also you can deploy it on-prem. So that's kind of the main motivation we build this. Yeah. So.
All right.
Yeah, so we can quickly go into the hyperparameters here, and then I will show you the fine-tuning logs. So we are doing a LoRa fine-tuning. LoRa is a way to do a fine-tuning of not the full model, but we have an adapter, which is like an external set of weights that we fine-tune. It's a small number of weights, so changing those weights is much cheaper than changing the full model. Um, and it runs faster, and you need lesser resources to fine tune this as well. There are some training dynamics parameter. Learning rate controls how fast your model learns. Number of train epochs controls how many times you see each example. So in this case, it's just one. So one example will be seen at once in the fine tuning. Per device train batch size is how many examples you fit into one GPU. So for me, the higher you go, the better you utilize your GPU. But beyond a certain point, it goes out of memory. So 4 is a good number for this data set and this model. And gradient accumulation step is again to make the training a bit more stable. It kind of increases the effective batch size of the training. There are some infra parameters which you can also add. These are just to like show how frequently we want to log and how many workers to do some pre-processing, just to speed up the data pre-processing. So when we ran this, we got a job ID. I will quickly show you on the viewer how we can see the job. So here is the job. It's called Bespoke DevRev Demo Live. And yeah, so you can see that there's the base model was Quen. It was created some time ago, just like some 5 minutes ago. The dataset ID, and it was started training. So the training loss reduces, which means it's good, and the model is learning. And you see, like, it was trained for one epoch. We also have some event logs, like the job was started, we loaded the dataset, and we started training, and the training was finished. And then we stored the final model. So this is the final model, and let me quickly uh, copy this, and I will show you how we can deploy this. So similar to fine-tuning client, we have a models client. And also here, you can see the models that were created, and you can see that it's pending. So it means it's not yet deployed, and we will quickly So deployment takes like 5 to 10 minutes. So in the interest of time, we already have a model deployed. There was fine-tuned on the same data set. So this is the URL that we get, and it's an OpenAI compatible endpoint. So you can plug this by changing the base URL and the model name, and any OpenAI client can do inference through this endpoint. Yeah, so this is the fine-tuned model. Let's see how it performs on the eval set.
And before we jump in, there is a question. Herschel is asking, what if we don't have a high capacity machine to work with an LLM model?
Yeah, so this infra is actually ideal because you don't need to have a high capacity machine. You just need this like collab type environment and create an account with Bespoke Labs, and you can then schedule your fine tuning jobs and deploy the fine tuned models and just use them through the OpenAI's API.
Yeah, I think the bespoke tooling here makes it really easy. So what we're doing now is we're taking that model, which Shreyas just trained, and we're going to evaluate it. So given that link where the model is now being served, we're going to plug this into our curator object, which does the inference on the evaluation data set. So let's just run this. We're taking a portion of the test data set, and we'll run it again. So I think that the key thing here is that you are going to measure how your model does, and then you're going to go back to the process of working on the data. So typically it's not a one-step thing, and you're going to iteratively improve the performance of your model. And I think it's also important not only to look at the static eval set, but as your model gets better, to also improve your eval set and look at production logs and also play around with the models that you train. Each of these things are going to be measuring something else. So, okay, so then we're going to load in the eval data set, and then we'll look at the final score. So you can see here, we've got a nice little performance boost on our evaluation data set. We went from 28% on the model we were using before, and now we are at 35%. So this is a testament to the synthetic data generation that we did a little while ago, and then also the fine tuning, which Shreyas did, where he picked the hyperparameters and the type of fine tuning. So these variables we could all continue to iterate on and make the model even better.
Mm-hmm. We've got a question from Custom. Does this work well with VQA tasks?
Yeah, that's a great question. So by VQA, for the audience, he's referring to visual question answering tasks, I believe. And right now, the model that we're fine tuning is completely text-based. But yes, when you're dealing with multimodal models and multimodal tasks, this entire process is going to look very similar. So synthetic data set generation and fine tuning and evaluation. So maybe Mahesh can jump in. We have a new multimodal model that
Right. Yeah, it's a great question actually. We recently trained 7B sized chart understanding. So just like, if you have plots and whatnot, so it's a visual VQA model specifically for charts. And there, I think I can kind of roughly describe the training recipe. again, it's a lot of synthetic data generation, right? So first step we do is distillation. We use Curator, and we take a large model like Qwen72B, and take some charts and generate some questions and answers. And so first we initially curate a good data set, and then we, just like what we did here, we fine tune a 7B model on that data. And then actually something interesting that we did is like we generated a lot of other, we take more charts and then generate 1 million or so examples or questions and answers from this fine-tuned model, not from a teacher model, but from this fine-tuned model, and then do some sort of rejection sampling. And then once you have a good data set, you kind of fine-tune again. And the other process we did was the DPO. Basically, what we found is that sometimes in the chain of thought of when the model is answering a question, there may be one step where it gets subtly wrong. So we kind of correct that and get a preference data set of, okay, here is a place that the model made a mistake, here is the right answer, and then do DPO on it. So that's the preference tuning that I was mentioning. So once we do that in these three successive cases, the model's improvement, gradually improves, right? So first we did the distillation, you get a boost in the numbers, and then we do the rejection sampling and further fine tuning, and you again improve, and then there is the DPO step, which finally gave us a pretty good boost. So that's actually the best 7B model, I would say, which actually does really well on chart understanding, and it's called Bespoke Mini Chart 7B, and it also in fact beats 3.5 Sonnet. So that's thanks for this great question.
Okay, perfect. So, I mean, just to recap where we are right now, we created a synthetic data set. We used it to evaluate our original baseline. It was pretty poor. We then decided to use a variation of that data set that was suitable for fine tuning. And we actually ran SFT. We actually, after one single SFT run, which obviously we would want to do some successive runs to get progressively better and better results. But after one run, we found that on evaluation, we came up with a result that was using a much smaller model and a more private model, and now is actually giving us better results. And what we can do now is actually take that result, that model that we've developed, and we can plug it back in to our original skill and actually have the skill work better than before.
Yeah. Let me show you guys how we can bring that model back to DevRev. Yes. So here we are in our skill again, and we can see that our LLM with structured output node actually has two configurable parameters. That's the base URL and model. And we can basically start calling the fine-tuned model from our workflow just by changing this. I'll just quickly do this. So I've got the URL. Let's update it. And similarly, let's update the model name. Yeah. And that's all we need to do to call the model and use the model in our workflow. So let's actually test a query and see if it works. So I'll try out a query which is usually a little bit complex for our previous model. It basically involves filtering on top of dates. So I want to query for tickets created since Feb. And which are modified in last 2 days. Yeah, let's see. So yeah, here, just to explain again, we see the thinking of our base model.
Okay, and we're going to be able to go to the workflow run and see exactly how it generated a query and filters as well?
Yep, let's actually do that. Yeah. So here we see that it found some tickets, but let's actually go and verify whether everything's working properly.
Mm-hmm.
So here I'm in the workflow run tab. I'll just quickly refresh our workflows. Yeah, here there's a new workflow run, and we see that our output is in fact correct. Created date is actually greater than February, and modified date is greater than 28, which is 2 days back. So yeah, that's how you can get any model to DevRev system and use it.
And you can go back to that search interface and maybe ask for the changes to be presented in a table view or something like that. Can we do that?
Yeah, let's try it out.
Okay, that way we're ready to go with this data.
Yep.
Let's have a look. Okay, fantastic. And you're telling me this wasn't working before. This wasn't going to work if we had asked this exact same question an hour ago.
Yep, that's correct.
Okay, sounds good. Well, we could do a lot better than where we ended up, but I think this is a fantastic way of spending 60 minutes learning about the different tools that we've got here, getting comfortable with establishing new skills and building models that can actually back those skills powerfully. Thank you, team.
Yeah, this was great. Thank you. Yeah.
Thank you, everyone.
All right.
Thank you, everyone.
All right.
Yeah.
So I think, Mahesh, we're going to have to do another one of these where we get into prompt engineering. Maybe we get into reinforcement learning and setting up rewards, and perhaps use even more sophisticated use cases where people can start to see the value of fine-tuned models, because here we're talking about accuracy, but there's also cost, privacy,
Yeah.
and so there's a lot to show for those who are interested, and we're excited to do maybe more of these in the future to bring more examples out there.
Absolutely. Yeah. Makes sense. Yeah. We should do that.
All right, let's do it. Thanks everybody for joining us, and have a great day. We'll see you next time. Take care.
Thanks.